Natural numbers. Natural numbers are the set of positive integers that originate from the concept of counting and represent whole quantities. They begin with the number 1 and continue indefinitely without including 0 or any negative numbers. This infinite sequence progresses by incrementing by 1 each time, leading to a series of infinity. They possess a sense of order. They follow a progression where each number comes after the one before it. For instance, 2 follows 1, 3 follows 2, and so on, indicating a natural ordering among them. Example counting objects, say, apples in a basket. You start with the first apple, which corresponds to the number 1. Then, as you continue adding more apples to the basket, you count 2, 3, 4. Each number represents a specific count or quantity of objects. Whole numbers encompasses the set of natural numbers along with 0, extending the concept of counting to include the absence of objects or quantities. In other words, whole numbers include all the positive integers starting from 1 as well as 0, but they do not include any negative numbers. They are used to represent quantities or counts, but with the inclusion of 0. They allow for a broader range of representations, including situations where there are no objects present. Integers. Integers represent a fundamental concept in mathematics, offering a comprehensive framework for understanding numbers beyond simple counting. Unlike natural numbers, which begin with 1 and extend infinitely, integers incorporate both positive and negative whole numbers along with 0, providing a more nuanced representation of quantities and values. The inclusion of negative numbers enables the representation of situations involving debts, deficits, or positions below a reference point. One notable characteristic of integers is their inherent structure, organized along a number line that extends infinitely in both positive and negative directions from 0. Rational numbers. Rational numbers represent a profound extension of the number system, encompassing fractions and decimals, and offering a precise means of expressing quantities that are not necessarily whole. The set of rational numbers comprises all numbers that can be expressed as the quotient of 2 integers, where the denominator is not 0. This inclusivity of fractions and decimals allows for the representation of values that lie between integers, facilitating finer granularity in numerical analysis and measurement. One defining characteristic of rational numbers is their ability to represent parts of a whole or divisions of quantities. Irrational numbers. Irrational numbers constitute a subset of the real number system, distinguished by their inability to be expressed as the quotient of 2 integers. This set includes numbers that cannot be represented as terminating or repeating decimals. Instead, irrational numbers possess infinitely non-repeating decimal expansions, making them non-representable by fractions. One of the most famous examples of an irrational number is the mathematical constant pi, which represents the ratio of a circle's circumference to its diameter. Despite numerous attempts, pi cannot be expressed as a fraction of 2 integers, nor does its decimal expansion ever terminate or repeat. Its decimal representation starts with 3.14159 and continues infinitely without forming a discernible pattern. Real numbers. Real numbers comprise a set of numbers that encompass all rational and irrational numbers. The set of real numbers includes both integers and fractions, as well as irrational numbers like pi and square root of 2. They are characterized by their location on the continuous number line, where each point corresponds to a unique real number. This continuum extends infinitely in both positive and negative directions, with 0 serving as the origin. One of the defining properties of real numbers is their completeness, meaning that every non-empty set of real numbers that is bounded above has a least upper bound, and every non-empty set that is bounded below has a greatest lower bound. Imaginary numbers. Imaginary numbers are a unique and essential component of the complex number system. They represent numbers that are multiples of the imaginary unit I, where I is defined as the square root of -1. Unlike real numbers, which can be plotted along a one-dimensional number line, imaginary numbers exist on a separate axis orthogonal to the real number line. This axis is often referred to as the imaginary axis. Complex numbers. Complex numbers are numbers that comprise a real part and an imaginary part. The real part represents a conventional real number, while the imaginary part is a multiple of the imaginary unit, denoted as I, where I squared equals to -1. In essence, complex numbers extend the real number system by introducing the concept of imaginary numbers, allowing for the representation of quantities involving both real and imaginary components. They can be visualized as points in a two-dimensional coordinate system, commonly known as the complex plane. In this plane, the real part of a complex number is plotted along the horizontal axis, while the imaginary part is plotted along the vertical axis. Each complex number is uniquely determined by its coordinates in this plane.